Welcome to this tutorial on AWS X-Ray, a powerful distributed tracing service. This is part of our AWS monitoring series, where we explore tools and services that help you understand and optimize your cloud applications. In this video, we'll learn how X-Ray helps trace requests as they flow through modern distributed applications. Let's start by understanding what distributed tracing is. Distributed tracing is a method used to track and monitor requests as they flow through distributed systems and microservices architectures. It visualizes the complete path of a request across multiple services, showing you exactly which services were involved and how long each step took. This helps identify performance bottlenecks and latency issues in your application. Most importantly, it helps you debug and troubleshoot errors in complex systems where a single request might touch dozens of different services. AWS X-Ray is a fully managed distributed tracing service provided by Amazon Web Services. It helps you analyze and debug production applications that are built using microservices architecture. X-Ray provides several key capabilities. It offers end-to-end request tracking, so you can see the entire journey of a request. It provides performance analytics to understand how your application is performing. It creates service dependency mapping, showing you how all your services are connected. And finally, it helps with root cause identification, making it easier to find and fix problems quickly. To use X-Ray effectively, you need to understand a few key concepts. First, there are traces. A trace represents the end-to-end journey of a request through your application. Think of it as the complete story of what happened from the moment a request entered your system until it left. Next are segments. Segments contain data about work done by a single service or resource. Each service that handles your request creates a segment with information about what it did. Finally, there are subsegments. Subsegments provide granular details within a segment. For example, if your service makes a database call or an HTTP request, those would be recorded as subsegments. Let's look at three more important concepts in X-Ray. First is the service map. The service map is a visual representation of all your services and their connections. It shows you how data flows through your application and helps you understand dependencies between services. Next are annotations. Annotations are key value pairs that are indexed by X-Ray for filtering and searching traces. You can add annotations to mark important information that you want to search for later. Finally, there's metadata. Metadata is additional data that you store with segments, but unlike annotations, it is not indexed. Metadata is useful for storing extra context that helps with debugging, but doesn't need to be searchable. Now let's understand how X-Ray actually works. There are four main steps. Step 1, instrument your application. This means you add the X-Ray SDK to your code, or you enable automatic instrumentation for supported services. Step 2, the X-Ray daemon collects data. The daemon is a software agent that listens for trace data sent by your application and forwards it to the X-Ray service. Step 3, data processing and storage. Once X-Ray receives the data, it processes it, indexes it for searching, and stores it securely. Step 4, visualize and analyze. Finally, you can view service maps, individual traces, and analytics in the AWS X-Ray console to understand your application's behavior. Integrating X-Ray into your application is straightforward. Here's a simple Python example. First, you import the X-Ray recorder from the AWS X-Ray SDK core library. Then you import the patch all function, which automatically instruments all supported libraries like requests, Boto3, and database clients. After calling patch all, your application will automatically send trace data for these libraries. To create a custom segment, you use the capture method with a context manager. Inside this block, you write your application code, and X-Ray will track the execution time and any errors that occur. This same pattern works across multiple programming languages with their respective SDKs. X-Ray integrates seamlessly with many AWS services. It works with AWS Lambda for serverless functions, API Gateway for REST and HTTP APIs, and Elastic Load Balancer for tracking requests through your load balancers. It supports EC2 instances running your applications, ECS and EKS for containerized workloads, and Elastic Beanstalk for platform-as-a-service deployments. X-Ray also integrates with DynamoDB to track database operations, and SNS and SQS to trace messages flowing through your queuing systems. This wide integration makes it easy to get comprehensive visibility across your entire OZ architecture. Using AWS X-Ray provides several significant benefits. First, you get complete visibility into your application's behavior and performance across all components. Second, you can quickly identify root causes of errors and performance issues, saving valuable time during incident response. Third, you gain a clear understanding of service dependencies and how services communicate with each other. Fourth, X-Ray helps reduce mean time to resolution, or MTTR, for incidents by providing detailed diagnostic information. And finally, you can filter and analyze traces based on custom annotations, allowing you to focus on specific types of requests or specific user scenarios. OZ X-Ray uses a pay-as-you-go pricing model, which means you only pay for what you use. The service charges you based on the number of traces that are recorded, retrieved, and scanned. There's a generous free tier that includes the first 100,000 traces per month at no charge. After you exceed the free tier, you are charged per million traces that are recorded. There are also additional charges for trace retrieval when you query your traces, and for scanning operations when you analyze trace data. This flexible pricing makes X-Ray accessible for applications of all sizes, from small projects to large-scale enterprise systems.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.